Greetings everyone. Today I and my teammate Liang from the FTG6 are going to present our fundamentals of computer networking assignment. The contents of this presentation are introduction, addressing design, the formula to calculate the subnet bits, the subnetting table, the addressing table, the network topology, the network configuration for router and switch, and we will display the pinging from one device to another device in the same network, between different networks, and between different locations, and how do data travel from one location to another when one of the connection between the routers are compromised. As you can see, this is a plan of what we came up with when TechX Solution hired us as their network engineers to design a local area network for their offices. As you can see, TechX Solution has three offices in different locations. Location A has administrative department, the sales department, and customer service department in location A. And 500 meters from location A is located location B, which consists of gaming tech department, big data hub department, and cyber security department. And 200 meters from location A is located location C, which consists of five different research and development labs. Now, I will let my teammate Liang to explain about the addressing design.
Thank you, Vengades. Hello, my name is Liang, and explain about the addressing design table. The addressing design table shows the calculation of the total number of usable host IPs required for each department. TechX Solutions has considered an 88% growth in the number of hosts, which also includes the number of routers and switches required. For example, the administrative department has 204 number of hosts required. To increase the number of hosts by 88%, we multiplied the number of hosts required by 1.88 to get the new number of hosts, which is 384. To get the number of usable hosts, we subtracted the new number of hosts required with the number of routers and switches and the broadcast and network hosts, which is 384 minus 20, which will then give us the total number of usable hosts of 364. The calculation process is the same for every department, for example, sales department, customer service department, gaming tech department, big data hub department, cybersecurity department, and research and development labs. And I'll now let Vengades, my teammate, to explain the subnetting table.
Before I explain about the subnetting table, I would like to explain about the formula to calculate the subnet bits. As we can see from the previous table, the administrative department requires the most number of usable host address, which is 384 host addresses. In order to create a subnet that is enough to contain 384 hosts, we need to assign 9 host bits. The remaining 23 bits will be the subnet bits. So the formula below is how we calculated the number of subnet bits. Let X be number of bits and let Y be number of IP addresses. So to calculate, this is the formula. 2 to the power of X equals to Y. Now that we want to find X, therefore by the rule of logarithm, log base 2 bracket Y equals to X. So the original calculation is log base 2 to 384 is because administrative department requires 384 usable host address, which will result in 8.58 bits, will then be rounded to the next closest integer, 9 bits. As you can see, this is the subnetting table. The uh, subnetting table shows the addresses, the IPv addresses, subnet mask, the network IP, the hostable host IPs, and broadcast IP for each department. And as you can see, we also allocated different second octet for every location uh, to make it easier to manage. For example, as you can see, location A would have the IPv4 address of 10.0.0, while location B would have the IPv4 address of 10.1.0.0. Now, I will let my teammate Liang to present about the addressing table.
Thank you, Vengades. I will now talk about the addressing table. The addressing table displays the IP address, subnet mask, and default gateway for each network interface and port used in the network design. The interface shows where the wire is connected to which port of the router, and the routers do not have a default gateway because they are the default gateway. And for the IP address, each location has a different second octet, and each department has a different third octet. For example, admin means admin department has a third octet of 0, and sales department has a third octet of 2, and CS department has a third octet of 4. And for location A, the second octet is 0, and location B, the second octet is 1. And for the GT department, is the third octet is 0, and the big data department has the third octet of 2, and the cybersecurity has a third octet of 4. Same goes to location C. It has a second octet of 2, and each department. Okay, I'll now let Vengades explain the network topology.
As you can see, this is the network topology that we designed according to the requirements given by TechX solution to us. As you can see, we have used one main switch and a sub switch to connect to the end devices. The reason for connecting the end devices like this are because um, each switch can connect up to 25 devices, 24 end devices. Therefore, we implemented a main switch to connect to the sub switches so that more end devices can be connected and facilitate scalability without compromising data transmission efficiency. This approach ensures seamless communication and swift data transfer across our network architecture, promoting optimal performance even as our network expands. And as you can see, we are we are connecting the routers from router A to router B and router B to router C, and also a connection from router A to router C. The reason we choose to connect the routers in this way is because even if one of the connection between, for example, the connection from A to B is compromised, we can still communicate with the end devices or the switches in location B by sending the data from location A to location C router first, and from location C router to location B router, and send the data to the end devices using these connections. Now, you can see that this is the detailed view of location A. As I explained previously, you can see that we are connecting the end devices to the sub switch, and the sub switch is connected to the main switch. This is detailed view of the location A, which consists of admin department, sales department, and customer service department. This is detailed view of location B. This is gaming tech department. This is big data hub department. And this is the cybersecurity department. And as you can see, this is the detailed view of location C, where we use one main switch to connect 5 different R&D department, because as per said in the question, it has 5 different sub R&D departments. So we use this manner to show to you that how are the 5 departments connected to each other. Now I will be explaining about the network configuration. First of all, I would like to explain about the router configuration. As you can see, we are configuring the hostname configuration. The reason for configuring the hostname configuration is to make it easy to identify the devices when we are trying to configure the commands for the router and set the protocol for the router. And the password configuration for VTY line 015 is because we could not allow other unauthorized personnel outside the company to access the router and change the configurations for the router. So this line of command and setting the password allows the unauthorized personnel from entering the configuration for the router, because when we enter the router, it would be asking for the password first before they could change any configurations. Same goes for password configuration line count 0. And for secret password configuration, it is because we are configuring the secret password configuration because it is uh, another layer of security for not allowing the unauthorized personnel from outside the organization to access the router and change the configurations for the router. And as you can see, we are also doing an IP address configuration for the router to make it easy for the end devices, the switches, and the router to communicate efficiently by allowing the end devices to identify their default gateway uh, and communicate with each other and other locations easily. And as you can see, we are also doing the routing. The reason for doing the routing is because to allow the devices, end devices in one location to communicate with other devices in another location. Now I will let my teammate Liang to present about the switch configuration.
Thank you, Vengades. I will now talk about the switch configuration. For the first command, it configures the device hostname for the console line in the switches to make it easily identifiable. And the next code will be the password configuration for the VTY line 0 to 15. It configures the password for the VTY lines of 0 to 15 in the switches. The VTY lines are used to remotely access the network device such as Telnet and SSH connections. Next. For the password configuration for line connection console 0, it configures the password for the console line in switches. It also secures the network devices. It is necessary because using a console cable is a very direct way to gain access to the terminal. And secret password configuration configures the enable secret for console line in the switches. It adds a layer of security to prevent unauthorized personnel from changing the network's device configuration. Next. The IP address configuration for switch. It configures the IP address for the switches. The IP address is configured on VLAN 1, which is the default VLAN for all switch ports, and it activates the VLAN. And I'll now let Vengades to do the pin connectivity.
So now I will be sharing how we are going to ping the devices from one location to another using the uh, devices from one end to another end. As you can see now, this is our network. So now we are going to ping admin PC1 from admin PC1 to admin PC2. The IP address of admin PC2 is 10.0.0.5. As you can see, we have received all the packets we sent without losing any. Now that we have pinged from PC1 to PC2, now we are going to ping from PC1 to main switch. And the main switch IP address is 10.0.0.2. As you can see, we have received three packets out of the four we sent, because the first time it was doing the ARP protocol. Now we will ping the same admin main switch again to show you that we can receive all the packets sent without losing any. As you can see, it shows that all the packets that we send have been received without losing any. Now, I am going to show you how am I going to ping from PC1 to sales PC2. And the IP address of sales PC2 is 10.0.2.5. As you can see, it was doing the ARP protocol for the first time, and we have gotten the reply for 4 packets we sent, and we have gotten 3 packets back. Now I will ping again to show you that we can receive all the packets without losing any. As you can see, we have gotten all the reply for all the packets we sent without losing any. Now that I have shown you the inter-network communication between different departments, I am going to show you how is the admin PC1 is going to communicate with the gaming tech PC1 in a different location. And the gaming tech PC1's IP address is 10.1.0.4. As you can see, we have lost all the 4 packets because it is from one different location to another. Now we will try to ping again to show you that we can receive the packets we send without losing any. As you can see, now we have received the reply from the PC Gaming Tag 1, which IP address belongs to 10.1.0.4. We have gotten all the 4 packets we sent without losing any. Now we are going to ping a R&D PC1 at location C to show you that location A, device PC admin PC2, admin PC1 can communicate with admin R&D PC1. So the R&D PC1's IP address is 10.2.0.4. As you can see, we have gotten 3 packets out of the 4 we sent because it was doing the ARP protocol for the first time. Now I will ping again to show that we can receive all the 4 packets without losing any. As you can see, we have received all the packets we sent without losing any. Now that I explained as before in about my network topology, even if a network is compromised, we can still communicate. For example, I am going to show how is the device admin PC1 is going to communicate with gaming tech PC1 even though the connection from A to B is compromised. Now we are going to ping admin the gaming tech PC1 from admin PC1. The gaming tech PC1 IP address is 10.1.0.4. As you can see, we have gotten all the replies from gaming tech PC1, even though the connection between router A to router B is compromised. This is because we have made sure that even though one of the line is compromised, we ensure that the data should still travel from router A to router C first and router C to router B. Now that we have shown you the communication, how the communication work between the routers even though one of the line is compromised. Uh, I am going to show you another example of how the data from location A to location C is going to travel if the communication line between A to C is compromised. For example, I am going to ping R&D PC1 from admin PC1, and the IP address of R&D PC1 is 10.2.0.4. As you can see, we have gotten 3 packets out of the 4 we sent because the first time it was doing the ARP protocol. And now I will ping again to show you that we can receive all the packets without losing any. As you can see, we have received all the packets without losing any. And this is the main reason we choose to connect the routers this way to ensure that the data can still travel even though if the network line between them is compromised. And this is all about our AACS 203 Fundamentals of Computer Networking assignment. Thank you for listening to us for these 20 minutes. Uh, and we thank our teachers for helping throughout the assignment. Thank you everyone for listening.